All right, so we're on page 34, Intro to Real Numbers. And now you're like, hey, Mr. Brown, don't you mean, aren't all numbers real? Yes. Well, yeah, so remember I talked a little bit about that number I. It's the square root of -1. It's a number that doesn't actually exist. Talked about that at the beginning of the chapter. So we're just going to talk a little bit about what real numbers look like. If you look at the top of page 34, it says extend the concept of absolute value to all irrational numbers. So basically they're showing you there absolute value. Remember, absolute value is just distance from 0. Yeah, distance from 0. Excuse me. And you've got 1, 2, 3, 4, -1, -2, -3, -4 there. They're just showing you, hey, like absolute value of a -15. Sorry, the negative absolute value of 15. That's how this reads. The negative absolute value of 15, which could be either right here between 4 and 3, or right here between -3 and -4. Um, so right there, or right there. And this distance would be the absolute value of 15, because it's positive, and sorry, square root of 15, and here would be the absolute value of -15. Now, both of those are both going to be the same number. They're both going to be a little bit less than 4, because absolute value can't be negative, as you should recall, because absolute value is just distance from 0. Yep, 0, and um, distance can't be negative. If you look down there, it says decimal forms of irrational numbers. So it's got the square root of 2. It's got pi. So this is about 1.414, and it keeps on going. 3.14159, da 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 da, keeps on going. And then that next number, I'll say that that's my best Greek alphabet drawing, but that is phi, and it's 1.618, and it keeps on going. This is a really interesting number. If you want looking, so phi is spelled like this, I believe. So if you want to just take this, and you can pause and go look up online, where is phi in nature? That's really, really fun. One of my favorite things in math. But I'm not going to take time in the middle of this lesson to look at it. But I would highly recommend doing that, as long as you can do that and still get your work done. All right, top of page 35. This is a really important bit. It says introducing the real number system and the real number line. So real numbers, so there's all these numbers here we're talking about are real. You have irrational, which means it cannot be m over n. And then doesn't repeat. Oops. Doesn't repeat or end. It's supposed to be or, not on. So irrational means doesn't repeat or end. And on this side, we have rational. So you should be writing this down on paper. So rational numbers means m over n. Anything where you can do m over n, that's going to be rational. So rational then gets split up into two different spots. I'm going to go to a next slide. You should have all this on one sheet of paper, though. You can see it on page 35 as well. But on the rational side, you could split into this side, which is non-integers, and this side, which is integers. So a non-integer would be something like terminating decimal, so like 3.24. That's not an integer. Or it could be something like 0.23, but you have the vernaculum over that, so that means the 2 and the 3 are repeating over and over again. So they're still rational. They can still be in m over n form, but they're not integers. Integers, remember, well, I will split up to two different kinds. The integers, you have two kinds. There are negative, and then there are whole numbers, and then whole splits into two, into positive and 0. That's right. 0 is special because it gets its own things here. So 0, I'm just going to write examples of all these. There's only one example of 0 at 0. Positive integer should be like 1, 2, 35, etc. Say 36, that looked a little bit more like that. Whole numbers just includes that. So whole numbers is like 0, 1, 2, 35. All of those are included in whole numbers. And then negative ones would just be like -1, -3, -64, whatever it is. So all of these, negative and whole integers, they're all included in integer. So if it's an integer, then it's here. Negative integers include these. Whole numbers means that it's 0, 1, 2, and then the whole numbers are split up into 0 and the positive integers. All right, next on the bottom of 35, it says order real numbers on a real number line. You can flip over to that next page. So basically what we're doing is we're taking the numbers and we're going to put them on a number line. So if you have A there on the top of page 36, it says, well, first of all, let's list out the numbers. 5 and 11 over 13, square root of 30, the negative 84 over 25. Oh, that's really bad. Negative 84 over 25, negative 8.283. But remember, only the 8 and the 3 have that. So the 2 does not have a vinculum over it. So the 8 and the 3 is what's repeating. And then the last number is pi squared. So it says, use a calculator, represent each number in decimal form with 3 decimal places. So I am going to switch this to red. And we're just going to try to list them all out. So 5 and 11 over 13. So I do 11 over 13 on my calculator. I'm going to get 5.846. I'm going to put dots after it to know that it keeps on going. It doesn't look, oh, it actually does repeat. Because I see 846, 1538, 462, and this is the last number. Look, 846153, 846, and then 1 and 5 should be next, but you see 2. That's because this is a 1 and a 5, but this number was cut off, so they round this up to be 2. So technically, if you ever want to say like, hey, what is going to be repeating, then you would say this, and then you would cut all of this off, 5.846153. Let's look at this next number then. Yep. Square root of 30, I'm just going to do square root of 30 on my calculator, which is going to be about 5.477. I'm not seeing anything out. Remember, square roots of numbers are often irrational, so this is an irrational number because it doesn't repeat, it doesn't end. Next number is negative 84 over 25. It's going to be negative 3.36. Next is negative 8.23. That's already the decimal. Negative 8.283. And this is repeating. And last number, pi squared. So I just take pi in my calculator and I square it. So you want to take pi exactly. Don't just do 3.14 squared. If you take 3.14 and square it, you're going to get a slightly different number. It's going to be really close. It probably won't make a big difference in this problem itself, especially because the whole point of this problem is you're putting it on a number line and trying to say which one's bigger or smaller. But you do want to be exact. So if you do pi squared, you're going to get 9.8696, and then it keeps on going. I would have done the 3 decimals there, but I already wrote the 9, and technically this would run up to 9.87. But anyway, so the first thing is just write all of them in decimal places. So you're going to do it a lot nicer on your when you do it on your assignment. But I would just, for my assignment, list out this, and then across from it, say what it is in decimal form. List out this, across from it, say what it is in decimal form. Do that for each one of them. Then for the next thing they want is they would like you to list out which one is the, let's see here, B, order the real numbers from least to greatest. So least, I'm going to look for any negative numbers. What's the most negative number? This one right here. Then the next negative is here. What's the next closest to 0 on the positive side of the negative line? Well, it looks like it's here. Then here, and that's going to be your biggest one. So if you notice on B, it tells you to actually do the actual numbers. So I'm going to have to flip back and forth here because this is going to be where I actually do my work, but I'm looking back here. The first one I list, again, it did say least to greatest, so negative 8.23, but that is going back to this, so I need to do the actual thing. Negative 8.2, what is it, 83 repeating? Yeah. Is less than, and then I'm just looking back. What's the number I have too? All right, negative 3.36, that's negative 84 over 25. Oops, my mistake, put a comma there. You don't want commas here, you're just saying, hey, it's less than. Let's see, number 3 here, which goes back to the square root of 30. And I'm running out of room, so I'm just going to write that next one on the next line. Then 5.846, which is 5 and 11/13. Yep, 5 and 11/13. Which is less than biggest one, which is pi squared. And you can kind of see that if you look on B in your book, it does have this is less than this, which is less than this, which is less than this, and it has that being the biggest one then. The one thing to remember for when you're doing these ones is make sure that you're doing the actual original number. These are helpful for telling what they are, but you do want to say what the actual original number is because this is exact. That's one of the things about using irrational numbers, which these are. When you're working with irrational numbers, well, let's see. This, I guess this one's not irrational. This one's not irrational. But I think the other one's, let's see, that one repeated. So I guess technically that's not irrational. But you kind of get the point. Some of them, they're just decimals that they're easier to understand. Well, maybe not totally, I guess, for this one. But they're the numbers they originally gave them to you, so they want you to put those original numbers back on there. And then for C, it says look at each real number approximately on the number line. So this, if you remember from the last lesson, I told you guys you didn't have to be exact. Same thing for this one, just kind of put it about where it's supposed to be. Anytime you're drawing your number line, these ones, you want to look at, hey, what's your lowest number and what's your highest number? So it's going to, our number line should go from -9 to +10. So I'm just going to put my number line on here, 0, -1, 2, 3, 4, 5, 6, 7, 8, 9, to +1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So -9 to +10. Remember, -8.23, so 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to say right about there. -8.283. Then -84 over 25, I'll look back to see exactly what that is. -84 over 25, that goes to -3.36. So I just look at -1, 2, 3. Somewhere in there is going to be -84 over 25. Then square root of 30, which is, I look at back on here, 5.477, so between 5 and 6. 1, 2, 3, 4, 5, and 6, so between there. Square root of 30, 5 and 11/13. I don't even need to look at that because I know it's 1, 2, 3, 4, 5, and 6. So it's going to be in there as well because 5 and 11/13. I don't need to look at exactly what the decimal is. I know it's more than 30, or it's going to be bigger than 30 because it was greater than it, right? So I just have to do 5 and 11/13. And then square root of this, which I believe was 9.86. Yep. So I just have to, I know this last one is 10. So I put pi squared right there. And then I'm done with that problem. Let's see, bottom of page 36, represent each real number as a decimal rounded to 2 decimal places. And then number 4, represent each number below as a rounded decimal rounded to 4 decimal places. We're going to skip 1 to 3 because they're a lot more simple. Number 4, I do want to do one more practice with you. So 4 is you've got 199 over 23. And then I'm going to fix my mistake from before, negative 12.054. I would recommend you write them the same way, kind of going down, so you can kind of say, hey, this equals about that, this equals about that, so on and so forth. Negative pi cubed, pi over 2, square root of 200, and negative square root of 289. So we got a lot of them on here. I'm going to switch to black. 199 over 23. All right, so I would go ahead and pause right here. Make sure you have these copied down, then go ahead and come back when you're done. Remember that you're going to need to locate each number on the real number line too. All right, pause, and we're back. 199 divided by 23 is going to give you about 8.65. Negative 12.04 is going to be negative 12.054. That's going to be actually exactly exact. The negative square root of 3, so negative pi cubed. Remember that exponents comes before multiplication. This is an exponent. This is technically saying it's negative times it. So you're not taking the negative, you're not taking negative pi and then cubing it. You're taking pi cubed. So pi, where am I finding that on here? Where's my caret? Just a second here. I am having technical difficulties finding my. There we go. Wait. Pi. Oh, there we go. Cubed. Pi cubed is 31. About 31 point. It's about 31 flat. Pi over 2 is going to give you about 1.57. Square root of 200 is about 14.14. And negative square root of 289 is exactly negative 17. Remember that square root, it's just saying it's the square root, but then it's negative. This is like multiplying by a negative 1. So that's what your final answer is. You can kind of look in the back to see what it looks like when you're going to put it on there to see what your final answer for that one is. You're going to have to go, look, your lowest number is, that would be your positive number. Oh, sorry, remember, this is a negative answer, so this should be negative 31. Let's switch to a different color to make it easier on all of us. So this is your lowest number, and then second, this is second actually, this is third. And then on the positive side, I'm going to switch to a different font just so that I know what's on the positive side. 4 would be the next because it's closest to 0, and then 5 and 6 is going to be your biggest number. So you're going to need to go from negative 31 all the way up to positive 14. So I might just go like negative 40 to negative 40 to positive 15 and go every 5, and then just put about where they're going to be. Remember, you're using the exact numbers again when you're doing it. I'm not going to go through the exact thing, but you can look in the back if you want to see it. You should be good to go for your assignment.